Hi everyone, it's Mrs. McInnes here. Welcome to lesson 1 of our new topic, which is similarity. So we're going to begin this topic by looking at similar lengths. So in maths, we would describe two shapes as similar if they are exactly the same shape but just different sizes. Okay, so two shapes where one is a larger or smaller version of the other. So we would know that these shapes are exactly the same if the angles are all identical and the lengths are in proportion to each other. So one shape will be an enlargement of the other, but it also could be a reduction of the other as well. So it could have been made bigger or possibly have been made smaller. So the formula for working out your scale factor is as follows. You would look at two matching sides in your two shapes and you would take the length in the new version of the shape and you would put that in a fraction over the length in the old shape. And then to work out a missing length, all you would do is multiply the scale factor by the corresponding length in the original picture. So for your notes, what I would actually like you to do is add a little bit here because I find that this is helpful for pupils when they're trying to write their scale factor out. So if you have a shape where you have an enlargement being made, so a smaller shape being enlarged to a bigger shape, what's been used here is called your enlargement scale factor. And the way that you would work this scale factor is you would take two matching sides in your two diagrams, so perhaps this side and this side, and you would use the big side over the small side. Okay, so if your picture's been made larger, the side on the larger picture is your new side and then the side on your smaller picture is the old side. But I find it helpful to describe it as big over small, okay, for some pupils. Equally, if you have a larger shape and you have made it smaller, we would call that a reduction. So it would be reduction scale factors being used. So the way we would work this out is we would use the pair of matching sides. We would use the small side over the big side. Okay, so the smaller side would be on the new shape, the big side would be on the original shape. So that's sometimes helpful for pupils when we begin this topic, and that's the way that I'm going to describe your examples as well. So let's try a couple of examples. Here we have example 1. We have two picture frames below that are similar and we're asked to find the length of side X. So we can see that the side that we're being asked to find is on a smaller version of the original picture frame here. So this side X is on the smaller one. So what's been done here is we've got a reduction has been made. So the first thing I need to work out is then going to be my reduction scale factor. And the formula I gave you for that was small over big. So the pair of corresponding sides are going to be the pair of sides that match on both pictures, the pair of sides where we have a number for each on both pictures. So that's going to be the 10 and the 25. So if we put that into our formula, smaller over the bigger one, 10 over 25, that is our scale factor. And we can go ahead and simplify that down. They both divide by 5, so you could simplify this down and we'll get 2 over 5. So that means that this smaller picture frame is 2/5 of the size of the bigger one, and that's our scale factor that's been used. So then all we have to do to work out side X is do our scale factor, which is 2/5, and multiply that by the side that matches the missing side. So our missing side here is X, so the side that matches that on the original picture is the 15. So we're going to go ahead and do 2/5 times 15. Okay, if we were doing this non-calculator, we are doing 2/5 of 15. So 15 divided by 5 is 3, and then times the 2 gives us 6 centimetres. Okay, so that missing side there is 6 centimetres long. For example, 1b, we have here a pair of similar triangles and we're asked to find the missing dimension X. So the side that is missing this time is on the bigger picture, so an enlargement has been made here. So if we work out our enlargement scale factor, it's going to be the big number over the small number. So if we look for our matching pair of sides, we have on this diagram here, the bottom side of each triangle matching, so 8 and 4. So that's the pair of numbers we're going to use, bigger number over the smaller number. So 8 divided by 4, that gives us a scale factor of 2. So this larger triangle is twice the size of the smaller triangle. So then to find the side X, we are looking for the side that corresponds with our missing side. So that would be the 3 across here. That's the 2 vertical sides of each triangle. So our formula here is going to be our scale factor times the corresponding side. So scale factor of 2 times the matching side, which is 3. So that actually again is 6 centimetres for that one. So we have an extension to this where we have what's called similar triangles. Now, two triangles are said to be similar if all of the three angles are the same size. So we often have various types of diagrams for similar triangles. Sometimes we have triangles like the one you can see here, where we sort of have one on top of the other. And sometimes we have them in a sort of X shape that I'll show you in the next picture. So for example 2, we have find the length marked X in each diagram below. So what's quite helpful to do sometimes is to separate out your triangles, okay? So what we can see here is you have a larger triangle with a smaller triangle on top. So if we separate out our triangles, we have the smaller one and then we have the larger one. So on the larger one, we have 40 millimetres at the bottom and we have 36 up the side. And then on the smaller one, we have 16 and we have side X. So sometimes it's helpful to take the picture and split it into your two triangles. So the side that is missing is this side X on the smaller triangle. So we're going to be using reduction scale factor here. So the first thing we'll do is work out the scale factor. So reduction is the smaller one over the bigger one. So our pair of sides that are corresponding in this case are going to actually be the bottom edge of each triangle, the 16 and the 40. So if we go ahead and fill that into our formula, we have 16 over 40. And we can simplify that down. They both divide by 8. So that's going to give us 2 over 5. So same as before, to work out the missing side, we're looking at the side that matches the one that's missing. So our corresponding side here that goes with the X is the 36. That's the side that matches. So if we use our formula same as before, we are going to be doing 2 over 5 times the side that matches. So 2 over 5 times 36. Okay, so if we were doing this without a calculator, okay, we would go across here, we do 36 divided by 5. So that doesn't exactly divide, so we're going to have a decimal here, that's fine. So 5 into 3 doesn't go, 5 into 36 would be 7, remainder 1. So we need to add a 0 to carry that remainder. 5 into 10 would be 2, so 7.2, and then 7.2 times the top number. So 7.2 times 2, so that's 14.4. And it's millimetres. All right, the last example I'm going to do with you is the last version of these triangles where we have a sort of X shape formed by our similar triangles, okay? Now, what's important to notice in these particular diagrams is that your pairs of sides that are corresponding are actually across from each other in the X shape. So the 3.6 and the 3 are the two kind of matching sides that we have here, and then the 4.5 and the X are the other pair of matching sides, okay? So that is how these diagrams are going to be laid out. So The side that we're being asked to find x here is part of this upper triangle. Now, sometimes it's a wee bit tricky to work out, is that the smaller or the larger? So look at the sides that we have a value for each, the 3.6 and the 3. Well, 3.6 is bigger than 3, so that makes this triangle at the top the bigger one, and then the triangle at the bottom the smaller one. So because the x is part of that bigger triangle, it's enlargement scale factor that we're using here. So it's big over small, and our matching sides are the 3.6 and the 3. So 3.6 divided by 3, that gives us 1.2. So your scale factor here is 1.2. Okay, your next stage of working would be to work out your missing side. So the side that corresponds with the missing side x is that 4.5. So our working is going to be for x, our scale factor, which is 1.2, times the missing side, which is 4.5. Okay, now if you're doing this without a calculator, what we could do is we could write 1.2 as a fraction, which would actually be 6 over 5. And then we can go ahead and do times 4.5. So 4.5 divided by 5 would be 0.9. And then 0.9 times 6 is 5.4. These questions could also possibly just be calculator. So if it's a calculator question or you're allowed a calculator, you can just go ahead and type that 1.2 times 4.5 to get your final answer. So the questions I would like you to try for this lesson are as follows. In the Unit 4 class booklet, it's page 18, question 1, 2, 4, 5 and 6. So those questions are all going to be similar to the ones that I've gone through here in the notes. So if you are having any difficulty with any questions, you're not sure if you're doing it correctly, anything at all that you want to ask, please come on to the live call on the Teams page and ask for help or leave a little comment, okay? And Miss Eunice will be there to help you. All right, thanks very much, guys, for listening, and I will speak to you all on Monday. Bye.